here we have a sum and difference problem, a trigonometric sum and difference problem that uses two inverse trigonometric expressions for angles instead of angles in degrees or radians. So remember, this is an angle. Inverse sine of x over 2 is an angle. Inverse cosine of rad 3 over 2 is an angle. So these are two angles, the difference of two angles. And then applying the sum formula or the difference formula, as the case may be, which I have written over here, I'm simply going to, it's just like a substitution into that formula, right? Let's take a look at that. So it's the cosine of the first angle times the cosine of the second angle minus. So if you haven't picked this up already, the formula tells me that if I'm doing the sum of two angles, I'm going to do the difference of these two expressions. If I'm doing the difference of two angles, I'm going to do the sum of these two expressions. So you can see I'm actually starting off incorrectly there. Actually want a plus, because I have a minus, so I'm going to want the sum of the two expressions. And then we'll go sine of the first angle, inverse sine, of x over 2, and the sine of the second angle. Okay, then we just have this big expression here that we want to be able to simplify. Some easy ones, right? The cosine of the inverse cosine of rad 3 over 2. That's just cosine undoing an inverse trigonometric cosine, an inverse cosine. So that's going to be rad 3 over 2, right? Similarly, the sine of the inverse sine of x over 2 is x over 2. All right, we can think about this one a little bit using a unit circle. Where is rad 3 over 2? The inverse cosine of rad 3 over 2. That's going to be an x-coordinate of rad 3 over 2, which is going to be here, right? Rad 3 over 2. 1/2 is the point, and that angle at that point is what? Pi over 6. So what's the sine of, so inverse cosine of rad 3 over 2 is pi over 6. That is the angle. What's the sine of pi over 6? Well, I go to pi over 6 on the unit circle and I take the y-coordinate, right? So I'm going to take the 1/2. And that leaves us with this one here, inverse sine of x over 2. So the way that I like to think about this is that inverse sine of x over 2 is an angle such that if I put it into a right triangle, the opposite over the hypotenuse would be x over 2. There are other ways to do this, but this is a way that I like to think about it. The cosine of this angle, which is here, is, given this right triangle, the cosine is the adjacent over the hypotenuse. So I need this adjacent side. And this is a right triangle, so I can say that adjacent squared plus x squared is equal to 2 squared. And then figure out what the adjacent side is. So that's going to be adjacent equal to 4 minus x squared, and that'll be square root. Put that here. And the cosine of this angle, which is this angle, is adjacent over hypotenuse. So that's rad 4 minus x squared over 2. Probably nice to do a little simplifying here. Let's call it rad 12 minus 3x squared, combining the rad 3 and the rad 4 minus x squared. I'm going to have a common denominator of 4 here, right? Both of those will be a denominator of 4. So plus this x, and then over 4. And that would be our solution. And the way that this would be worded would be to say evaluate this and find the algebraic expression for this expression. And that's it.